Hello everyone, welcome to this video. In this video, when we are motivated for the Scalase theorem and know what it tell us, right? So we know it for every group we have a group of permutation which is isomorphic to group. Then let's see an example corresponding to this. So suppose we are taking the group U12. Now what is this? This is a multiplicative group, right? This is a multiplicative group modulo 12. So that means it would consist of all the integers which are relatively prime to the number 12. So that means the GCD of those numbers, say x with 12, that should be equal to 1. So those x, they are 1, that is 5, that is 7, and that is 11. So they are the members of this group. Now for notation, this U12 bar, that represents the group of permutations from the groups group elements of U12 only. So how we may represent the elements of U12? Let's have a look. So they are basically the permutations. So the permutations, the notation that we are using is T subscript x, right? So this Tx represents a permutation where we are multiplying all the elements by x and then taking modulo 12 of it, right? So we are again getting back one of the elements 1, 5, 7 and 11. So that forms the different permutation for the element for the group U12 bar, right? So the first element T1 is we are multiplying each element by 1. So 1 multiplied by 1 modulo 12 is 1. 5 with 1, that is 5, modulo 12 is 5. Then 7 with 1, so that is 7, modulo 12 is 7 only. 11 multiplied with 1, which is 11. When we take mod 12 of it, so it is just 11. So we have these entries. So this represents the identity permutation. For the next one, we have T5. Now T5 means multiplying each of the element by 5, right? And then taking modulo 12. So 1 into 5 is just 5. When we take 5 mod 12, right, it is equal to 5. So the answer is 5. Next we see for the element 5 into 5, that is 25. So 25 mod 12, that is, so when you divide 25 by 12, you would have the remainder as 1. So your answer is 1. Similarly, when you multiply 7 with 5, right, 7 with 5, that is 35, and when you take mod of 12 to 8, so you are basically dividing the number 34 with this 12. So we are having it is 35. So we are having 11 as the remainder. So 11 is the answer here. Similarly, when you have 11 multiplied by 5, so you have 55 here. So when you take 55 mod 12, so that means you are dividing this 55 by 12, right? So you would have 48 here. So it would be 7. So your answer is 7 here. In a similar manner, you multiply each of the elements with here in T7 with 7. So it is 7 into 1, 7 into 5, 7 into 7 and 7 into 11. Then you take their mod 12 and these are the answers. And similarly for T11, we can do the same thing here. So in this way, we have these 4 permutations with us which form the member of the group U12 bar, which we are calling the group of permutations. So according to Calais theorem, they say this group U12 consisting of these 4 elements T1, T5, T7 and T11, right? This and this, and then the group U12, they are isomorphic to each other. So let's see how this is there. So for seeing that thing, we may draw the Calais table for each of the groups U12 and the group U12 bar. So for U12, first of all, we have the elements 1, 5, 7 and 11. The operation is multiplication. The operation is multiplication modulo 12, right? So what we are doing, we are multiplying the element 1 with 1, which is 1. 1 modulo 12 is 1. 1 next 5 with say 7. When you multiply 5 with 7, so that is 35. 35 mod 12 is 11, as I have just told you in the starting. So in a similar manner you can complete this Cayley table. For example, we are talking about this particular element. For this element we have 11 here, we have 5 here. So basically what we are doing, 11 into 5, which is 55. So we are taking 55 mod 12. When you divide 55 by the number 12, you would have 7 as the remainder, right? Because you would have 48 here and 7 is the remainder. So the answer is 7. So therefore we wrote 7 here. In a similar manner you can complete this Cayley table over here. Next we will complete the Cayley table of U12 bar. So the elements here are permutations, which are T1, T5, T7 and T11. So we have written down the elements here and here, and we are just multiplying these two permutations. Now you know how to multiply permutations. We have seen in the previous video, when we have two different permutations, we can multiply them easily in array form. So after multiplication of each of these elements, you have these elements. So you can perform these 16 calculations and write down the answers here in place of circles marked, right? So you will have these answers. So this form your Cayley table. Now you can compare the Cayley table for U12 and the Cayley table for U12 bar, right? You can see we have 1 here, we have T1 here, we have 5 here, we have T5 here, 7 here, T7 here, 11 here, T11 here, then 5 here, T5 here, 1 here, T1 here. All the elements, they are obtained by multiplying these entries, right? And then taking mod 12. In this case also we are multiplying them and taking mod 12. In this case they are permutations, we are just simply multiplying them, right? Next 11 T11, 7 T7, 7 T7, then 11 T11, 1 T1, 5 T5, then we have 11 7 5 1 11 T11 T7 T5 T1. So therefore you can see that these elements, they are similar to each other, but the notation is different from each other. So this is what we are saying. When we compare the Cayley tables for both of these groups, we observe that they are different to each other just in notation, and both of them represent the same abstract mathematical structure. So this is the power of this Cayley theorem, that shows very similar to this, that this group is easily represented by the group of permutations, and both of them, they are isomorphic to each other. So I hope you understood this example well. Well, that is it for this video. Thank you for watching.